Hey, it's Emily from the Psych 2220 Learning Lab, and I'm going to help you with stating hypotheses for a one-tailed test. First off, I'm going to start you guys off with an example because generally a one-tailed test is more trickier for students than two-tailed tests because you have to decide directionality. So we will be walking through this example to help you with the process. So our example is the average student debt of OSU seniors greater than the average student debt of college seniors in the United States? State the hypotheses. So some things to think about are what words indicate that this is a one-tailed test. So words like greater than, less than, more than, anything that assigns directionality to the statement. And then what is the dependent variable? Here, our dependent variable is going to be average student debt. And our independent variables are going to be OSU seniors or all other seniors in the United States. So now we are going to start with our null hypotheses. In symbolic notation, if we have a statement that says, we hypothesize that mean 1 is greater than mean 2, our null is going to want to say the opposite. So our null will say H naught equals mean 1, mu 1, is less than or equal to mu 2. And if we say that our hypothesis is that mean 1 is a less than mean 2, we will also do the opposite and add an equal sign. So we will say that H naught is mu 1 is greater than or equal to mu 2. And for this example, we stated that mean 1 is greater than mean 2, so we will choose this first one. And our graph will look like this. Now for the alternate hypothesis, the symbolic notation, if we hypothesize that mean 1 is greater than mean 2, it will be exactly that in a symbolic way. So mu 1 is greater than mu 2. And if we hypothesize that mean 1 is less than mean 2, then it is going to go directly into that symbolic notation as mu 1 is less than mu 2. And for this example, we hypothesize that mean 1 is greater than mean 2, so this will be our symbolic notation. And yet again, this is what our graph is going to look like, or our normal distribution. Now for the written hypothesis, the null should be, should also indicate the same notation as before. So if we hypothesize mean 1 is greater than mean 2, the average student debt for OSU seniors will be less than or equal to the average student debt of all senior college students in the United States. And if we hypothesize that mean 1 is less than mean 2, we are going to want to say the opposite also. So the average student debt for OSU seniors will be greater than or equal to that of all college seniors in the United States. And now for the example that we are doing, this will be our proper written hypothesis for the null hypothesis. Onto the alternate hypothesis, or H1 or HA for notation. If we hypothesize that mean 1 is greater than mean 2, we are going to say just that. The average student debt for OSU seniors will be greater than the average student debt for all college seniors students in the United States. If we hypothesize mean 1 is less than mean 2, it will be just that as well. So the average student debt for OSU seniors will be less than that of all college students in the United States. And this will be our proper alternate hypothesis for our example. I hope this has helped, and I also just have some reminders to help point out that when you are doing a one-tailed hypothesis test, you are always going to have that little bar under your H naught, your null hypothesis, to say that it is either greater than or less than or equal to. And that is a very important part of one-tailed hypotheses notation and writing. All right, guys, I hope this helped.